In this video, I'm going to be repairing and upgrading this M2 Apple Mac Mini. Now, while I was at VCF East this past year, a fellow YouTuber who was also there, Action Retro, brought this machine to me and asked me if I could fix it. And basically, he told me it just doesn't turn on anymore, and it's due to some soldering issues on the back side of this board, which I'll show you in just a minute. But basically, he just gave it to me, said it didn't turn on, asked me if I could fix it, and I was like, sure, I can probably fix it, no issue. And while I was talking to him, I also said, hey, while I have it, maybe it'll be fun to upgrade the storage on it as well, since obviously I've done that in some previous videos, which you might have seen. So he's like, sure, go ahead and try it. So that's exactly what we're going to do in this video. So as you can see here, this is a base model M2 Mac Mini with the single 256 gigabyte NAND installed. You can see the empty pads for a second NAND right here. And what I've got here to upgrade it with are two 1 terabyte NANDs. Now these are the highest capacity NANDs that these boards support for a maximum of 2 terabytes of storage installed. So before we get started here, I'm going to flip the board over, show you exactly what the issues with it are. We'll give it a quick test, and then we'll go from there and begin the repair process. Alright, so as you can see here, I've got the board flipped over, and right in this area is where our problem is. So you can see the first issue here is this connector for the power button on the rear I/O panel has been completely removed. Now I think he was using this to, or he did this to try to solder some wires here, I guess, to have like a remote power button, which actually there are power button pads on the opposite side of this board that are a lot easier to solder to, so I'll definitely recommend he use those next time if he ever tries this again. But the main issues here are this component right here, this little 4-pin BGA chip is completely missing, and then this component right here, while it's not missing, it has been a little bit moved off of its correct solder pad positions there. So we'll go ahead and flip it over. You can actually see that that component is still attached to the board with no problem. I think it's just a 2-pin component, but you can see one piece of solder right here that's connecting that side, and then the other side is just being connected normally there. It hasn't really moved all that much out of position. So basically, in order to repair this board, we essentially just have to repair these issues. So install this chip, fix the alignment of this, not that that's actually causing an issue because it's still connected, and then in theory we'll have a fully functional system. But before I begin the repair, I'm just going to go ahead and get this hooked up to a power supply, attempt to turn it on, and show you exactly what it does currently. Alright, so now with the board all plugged in here, let's go ahead and hook up or plug in the power and attempt to power it on. So as you can see, it hasn't really done anything yet. So now I'll try to short out the power on pads like I mentioned before that are on the top side of the board here. And as you can see, it does absolutely nothing. So like I said, the board is completely dead, likely due to that missing BGA component. So let's get the board back out on my workbench and we'll begin the process of repairing it. Alright, so as you can see here, I've gotten the board out and ready to begin work on it. But as you might notice here, I've actually got two boards out here. And the reason for that is because this one right here is another board that I bought off eBay that's iCloud locked that I got just as a donor board to fix this one. Now, because I don't have schematics for these boards, pretty much no Mac Mini has available schematics, unfortunately. I don't exactly know what components those are, and the markings on such a small component aren't enough to actually figure out what it is. So to play it safe here, I think I know what it is, but just to play it safe here, I'm gonna just take one off of the donor board instead, and then we should be able to solder that onto Action Retro's board without any issues, and it should, in theory, resolve the problem with it. Now, another thing I just noticed here on Action Retro's board is that this screw hole right here seems to be a little bit wallowed out. I don't know, I guess he probably tried to put in a larger screw than this hole, so it kind of wallowed it out a little bit. Hopefully that's not causing any problems. If it's big enough, it could potentially cause shorts between the layers of the board in this area, but we're going to just hope that's not the case for right now. Get those components replaced, and then we'll go from there and see if there's any further repairs that need to be made. So with that, I'm going to get the donor board on the preheater, and we'll begin removing that BGA component. Alright, so as you can see here, I've got the board up on the preheater, and we're ready to begin removing that tiny component. Now, looking at the other component, the one I thought was only 2 pins, actually does have at least 4 pins here, so I will have to remove that from the other board and fix those brazed pads as well. But for now, we'll just get this little tiny component off, and you can't even tell, but pin 1 is in this bottom corner here, so just keep a mental note of that. And first, we'll just apply some flux and use the hot air to remove the part. It's probably going to melt this connector, but I don't really care on this board. Okay, so as you can see there, we've got the component removed, and it actually left a good amount of solder on the component as well, which is good. Alright, I've got it set in a good spot where I'm not going to mix it up. So now we'll get the other board, the one we're actually repairing, up on the preheater, and clean those pads and then get that chip soldered on. So the first thing I'm going to do is go through and tin all these pads using the soldering iron. And with that done, we're just going to take that tiny BGA component. We're not even going to reball it because it's already got solder on it from when it was removed. We're going to attempt to get it aligned and heat it to solder it into position. Okay, and that looks good there. So now what we need to do is heat and remove this other component that got messed up. And you can see there that indeed this component should have 4 pins. You can see some of them are a little bit bridged right there. So that definitely needs to be fixed. So we'll just tin those with the soldering iron as well. And unfortunately, after doing that, it looks like we have lost a pad here. So I'm going to have to check that under the microscope and see if I can figure out what that pad is supposed to connect to. And hopefully I should be able to repair that as well. It's not going to be easy, but we'll see. Alright, so after a good bit of careful inspection and testing, it looks like we got very lucky, and that pad that's missing is actually a no-connect pad. So just to point that pad out, here it is. That one right there, you can see we've got the other 3 intact still. And it looked like a no-connect pad because I didn't see any vias or anything in the pad or any traces connecting to it. So I think we'll be good to just solder that component back into position. So let's get some flux applied, and I'm going to heat it a little bit just to spread the flux out a little bit more. And we will just take that component and get it soldered back into position. Okay, and that looks really good there. So I'm going to give it one final inspection under the microscope and make sure everything looks good, and then we'll get it all hooked up and give it a test once again. Alright, so everything looks to be pretty well soldered on here. So you can see the 2 components right here. You can see that 4-pin component right here. That looks to be soldered on nicely. You can kind of make out the solder balls under there. Yeah, that looks really good there. And then right next to it here, we've got that little 4-pin BGA. That looks really good. It's sitting evenly. Can't really see the solder balls on that one because it's sitting so low to the board. But that's that component there. I've got verified that pin 1 is in the correct location based on the other donor board that I've got. So in theory, we should be all ready to test. So let's hook it up and give it another test and see if our repairs were successful. Alright, so as you can see, we've got the board in position once again. So let's plug it in and attempt to turn it on one more time. Alright, so it's plugged in, nothing yet, so let's short out the power on pads like we did before. And we got a chime. I don't have a monitor or keyboard or anything plugged in, but let's get that stuff plugged in, and hopefully it just fully boots and works as expected. Alright, so now we've got everything connected, so let's power it on. Okay, it's in recovery mode for some reason. Guess I held down the button a little too long. Let's see what happens here. But so far, so good. And there it is! We're booted! Everything is working! Now, I don't, of course, know his password, so I'm not going to log into it. But there it is, it's on and up and running. So now, of course, the next thing we need to do is begin the process of upgrading the onboard storage. Alright, so now we are ready to begin the process of upgrading the onboard storage of the M2 Mac Mini here. But first thing I want to show you is that in this instance on this M2 Mac Mini, this upgrading process is actually going to be quite a bit easier than it normally is on other systems with only one NAND installed. And the reason for that is if we flip the board over here, you can see that both sets of NAND pads have all their passive components already installed. So if you've seen my previous video on upgrading a M1 MacBook Air, we went from a single NAND 128 gigabyte configuration to a dual NAND 2 terabyte configuration, and in order to do that I had to repopulate a bunch of these tiny passive components on the underside of the NAND so that the second NAND would actually function when we installed it. And as you can see here, in the case of this M2 Mac Mini, those components are already installed, so we don't even need to do that. So literally all we need to do to perform this upgrade is remove the original NAND chip here, and then just solder the two NAND chips on the correct pads, and that's it. So with that, we will begin the process of removing and replacing this NAND. Alright, so we're now ready to begin the process of upgrading this system, and I'm not going to go into too much detail in this particular video, but if you want to see this process in greater detail, go ahead and check out my previous video where I upgraded the storage on an M1 MacBook Air. In that video I go into a lot of detail throughout this entire process. But for this video, I'm just going to make it pretty quick here. But you might notice one difference between the M1 machines and this machine is the type of NAND that it actually uses. So in the case of the M1, it actually used BGA 110 NANDs, which actually look like this and have this footprint. But as you can see, these NANDs are what are considered BGA 315 NANDs, and they have a much denser footprint and also have a lot more pins as well. So the process is a little bit different with these, but other than the footprint itself and the stencil needed to reball it, it's pretty much exactly the same process. So we're just going to go through and do that, and of course we'll start by removing the underfill. And now that the underfill has been removed from the perimeter of the chip, now we just need to use this tool to remove the NAND off the board. And with that removed, we just need to remove the residual underfill. And with that done, we just need to clean and tin the pads using the soldering iron. And with that done, we just need to clean the pads. And everything looks good there. So now we need to prepare the new NANDs to be installed on this board. And of course, to do that, we need to reball them and apply fresh solder onto them. Alright, so I've gotten the NANDs prepared to reball, and as you can see here, I've gotten a stencil out here, and this one actually supports reballing 4 of them at once, which is pretty nice. Now, I haven't actually ever used this particular stencil before. This is actually my first upgrade I've ever done with the BGA 315 NANDs, so hopefully this all goes well. But let's just go ahead and first apply each NAND to its respective footprint on the stencil, just using some Kapton tape. Alright, so as you can see there, I've gotten both NANDs applied. So now with them on in position, we just need to use some solder paste to apply solder to each pad. Alright, so that looks pretty good, and my only fear here is that the stencil might try to warp on me and cause issues with the second set of pads, but we'll try it and see. If I have to do one at a time, I'll redo one of them and do it separately. But I think this will work just fine. So let's turn on the hot air and attempt to reball both of these chips. Okay, so I think both of them turned out pretty well, but we'll take them off here and check in just a minute. Alright, so I do like how this one came out, but I don't really like how the other one came out. I think the stencil warped while I was soldering the first one and caused some of the balls, or some of the paste to run underneath the stencil. So I am going to go ahead and redo that one. But the final step on this one is to apply some more flux, just like that, and then heat it one more time off of the stencil. Okay, yeah, so that one looks really good there. But like I said, I am going to redo the other one. So I'm going to do that real quick off camera, and then we'll be prepared to install them onto the board. Alright, so I'm definitely a lot happier with how that came out the second time. You can take a look at it right there. That looks really good. Here is the first one as well. That one looks pretty much perfect as well. So that is exactly what I want to see. So now what we need to do is simply get those chips aligned to the pads on the board, which is going to be a little bit more difficult than it is normally with the BGA 110 NANDs, but we shouldn't have any problem doing so. So first we'll apply some flux. Not too much because we already have some on the chips. We'll take our chips with pin 1 in the correct position, of course. And there was still some residual underfill left over that I didn't wanted to remove to make sure it wasn't going to cause any problems. So with that taken care of, now we can get the chips aligned into position. Alright, so those are definitely a lot more difficult to get aligned than the BGA 110 NANDs, but I think I've got them, so now I'm just going to heat them and hopefully they solder into their correct positions. Okay, so visually they look pretty good. So now, of course, all we need to do is get the board hooked up to another Mac, get it booted into DFU mode, and attempt to restore software onto the device. Alright, so as you can see here, we've got the Mac Mini hooked up to a M1 MacBook Air, which we're going to use to restore software on the device. And I've got it plugged into the correct USB-C port there. So now what I have to do is I have to plug in the Mac Mini while holding the power button pads shorted in order to get it to boot into DFU mode. So I'll attempt to do that now. Okay, so you can see the device is indeed in DFU mode. So now what we need to do is simply restore software onto the device. Alright, we've got an Apple logo on the Mac Mini, you can see right there. And we've got a moving progress bar on the Mac Mini, which is a really good sign. Alright, and it is definitely working now, I can definitely tell. So that's good. That means our NANDs are soldered correctly, they're aligned, they're working as expected. So now we just simply have to wait here for the restore to complete. Alright, as you can see, the restore has completed successfully. So now we need to get the board reassembled, get the heatsink and everything back on, and we will give it a final test. Alright, so as you can see, I've gotten everything assembled, and I would use the power button to power it on. I did reinstall the power button ribbon cable connector on the board that was removed, but Sean's I/O plate doesn't actually have the power button in it anymore. I don't know why he took it out, but it doesn't have the power button in it, so I'm just going to use the tweezers like we've been doing to power it on with the power on pads. And as you can see, it chimed as we expect. And just like that, we're in macOS. So let me go ahead and run through the first time setup, and then we'll take a look at the final system specifications. And just like that, we're in macOS and we've completed the setup. So let's go ahead and take a look at about this Mac. You can see that this is a 2023 M2 Mac Mini. You can see it just has 8 gigs of RAM, of course the base model. And the moment of truth here, there it is, 2 terabytes of internal storage. So let's go ahead and go into System Report here. We'll check NVMe Express, and there it is, AP2048Z. 2 terabytes of soldered internal onboard storage. So that has been the successful upgrade and repair of this M2 Apple Mac Mini. So with that, I hope you enjoyed this video.